All right, good morning. You're going to be working today with equations that are a little bit harder. They have more than one variable, so they're going to have like terms. So before, let's review what like terms means. So like terms just means that the term, the group of letters and numbers, have the same variable. Sometimes it could be variables, right, if that has an x and a y, and the same exponents or powers. So it has to be the exact same combination of both of those things. So if we look at some examples down at the bottom, if we start with number 1 and it says match the terms on the left, that's these terms, with the like terms on the right, that's these terms. So the letters and the numbers. So we have 7x, okay, and we're looking for a term over here that could be like with it. So if I look at 7x, I go over here, I can say, ooh, negative 9x, because they both have an x. It has nothing to do with the number, right? It has to do with the letter and the exponents. These both do not have an exponent visible, right? We learned that they have an exponent of 1, but technically we don't see the exponent there. So x and x are like terms. So 7x and negative 9x, if I combined them, right, I would get a negative 2x, right, because 7 minus 9 should give me a negative 2, right? So combining just means putting the two numbers together. So again, if you had a calculator out, right, you could do 7 minus 9, or you could do negative 9 plus 7, right, because we have a negative 9 and a positive 7, right? I have a negative 9 and a positive 7. So those two things together would give you a negative 2, and you would keep the x. If I look at the second one, I've got a negative 4ab. Well, I'm looking for a term that has an a and a b. Well, only one term has that, the last one, f, down here. So I have negative 4 and negative 12. If I combined those two, right, I have 4 negatives and I have 12 negatives, so I have lots of negatives, right? Together, I have 16 negatives, right? I have negative 16 and then AB. If you have trouble doing that in your head, right, remember, you're just using the numbers here. What is this number? Negative 4. And what is the other number? Negative 12. So I can write it as minus 12 or negative 12 and put those two together, and it will give me a negative 16. It doesn't matter if I put the negative 12 first, right? It does matter that I use the minus when I'm doing an operation here. I'm sorry, I put the negative. So negative 12 minus 4, right, is negative 16. So I get negative 16 AB. All right, you're kind of seeing, hopefully, or remembering how this works. We practiced some of these a couple weeks ago. So negative 3x squared, again, it has an x. So some people might be tempted to say it goes with the x term, but it has to have the squared. Remember, it has to have like exponents too. So squared, x squared. And it has to be exactly the same. So this one has an x squared, right? But it also has a y, so that won't go together, right? I need it to have exactly the same combination. And so number 3 goes with letter B, and we have negative 3 and positive 8. I've got 8 positives and 3 negatives, so 8 minus 3 would give me a 5x squared, right? Positive 8 and negative 3, or negative 3 and positive 8. Either way you think about that, it should be a negative. There are more positives than negatives, so my result will be positive. All right, here I have a negative y to the third power. Well, I'm looking for one that has a third power. Well, there I see 12 y to the third power. So I'm going right here. Be careful with this one, because when you do combine them, this is a negative y, but remember that's always a negative 1y. So I have minus 1y and positive 12. Well, I have 12 positives and 1 negative. So 12 minus 1 will give me 11, right? 11y to the third. Keeping going, we have 5 is 3y, and there's only one that has just a y, right? This one has an x and a y. It does not go with the one with a y. It has to have both combinations. So 3y and negative 5y. Again, negative 5 is more than 3. So my result will be the difference of those two, right? I've got 5 negatives, and I've only got 3 positives. My 3 positives cancel with 3 of my negatives, and I've got 2 more negatives left over. So I've got 5, or 3 minus 5, or negative 5 plus 3, right? Either way you do that, you will get a negative 2. Okay, those are saying the same thing. The negative 5 is here, the negative 5 is here, the positive 3 is here, the positive 3 is here. They basically say the same thing in the opposite order. So negative 2y for that one. And then the last one is easy to match because there's only one left. So 8x squared y and negative x squared y, we get this. So again, remembering that this is an 8 and this is a minus 1. Okay, so if this is positive 8 and negative 1, you guys should be able to do 8 minus 1, hopefully in your head, and you get 7x squared y. Okay, so just a quick review of those exponents and variables that make things like terms. So before I can use these to solve inverse operations, I need to get my variables together. And I need to combine, which is another way to say get together. I need to combine my constants. So let's look at the first example. Draw a line where your equal sign is. We're looking for like terms. 16 is on the left side. It has nothing like on its side. On this side, I have 3 terms. I have a 4a, a 6, and a negative 2a. 2 of those are like terms, and you might see them right away. There's a 4a and a 2a, right? Or a 4a and a minus 2a, I should be saying. 4a and a minus 2a. When I combine those two, right, 4a and minus 2a, positive 4 minus 2 is going to give me 2a. I didn't combine the positive 6 with anything, so it just comes down in my equation. I didn't use the 16, so it just comes down in my equation. Once I have those 2 like terms combined, I really just have a 2-step equation, which all of you have already mastered because you've proved that. So this is a positive 6, right? I'm going to move my positive 6 using a negative 6. All right, so my positive 6 and negative 6 give me 0, and my 2a is still there, I didn't use it, and my 16 minus 6 gives me 10. And then my 2 is being multiplied by a, right? When they're right next to each other, that means they're being multiplied. So I'm going to go ahead and use the opposite of multiplication, which is division, to divide, and then dividing here. These 2 will cancel, and I'll get a equals 5. Because 10 divided by 2 equals 5. So I'm going to pause for a second here, and I'm going to have you guys try the example over here, which looks very similar to this, same type. So take a second and try that out. All right, as you can see, I've added the answer for this, and it does end up being a decimal. In life, things end up being decimal a lot more often than they end up being an even number. So you were still combining the negative 1p and the 6p, right? 6 minus 1 gave you 5p, and you still had the negative 4, so you added the 4 and got 12, and then divided by 5. Well, 12 divided by 5 does not divide evenly, so you got a decimal. That's okay. If you left it as 12 over 5 as a fraction, that's fine. If you put it as a decimal, that's fine too. All right, let's go on to the second example. Here, we're going to have to use some distribution to start our problem out. So we have 5n minus 2n, right? We're going to do 2 times n and 2 times 4. Just like when we see parentheses, we know we need to distribute there. So we've got 5n minus 2n, and then negative 2 times positive 4 is going to give me a negative 8. And that equals 4 still. So I still have the same answer on this side, nothing changes. But now I can see my 2 like terms are 5n and minus 2n, right? So 5n minus 2n should give me 3n. Because 5 minus 2 is 3. So I've got 3n minus 8 equals 4. And now I just have a 2-step equation, right? I'm going to move my constant or my number over with the other constant. So I'm going to add 8, and I should get 3n is equal to 12, because 4 plus 8 equals 12. And the last step will be dividing by that number in front of the n, which is a 3 in this case. So these are going to cancel, because 3 divided by 3 is 1, right? 1n is what I want. And so I get n equals 12 divided by 3, which is 4. Again, pausing for you to try the number 2 on the other side. Give it a shot. Let me know. I'll put the answer up in a second. If you have any questions, please let me know. Okay, on that right side, you should have gotten 150 for your m, right? So if you are multiplying this out, you get a 10m, and then you get a minus 130, and then you combine these two, you get a positive 1m, or just m, and then you still need to subtract 130, so you're going to add it to the other side, and 20 plus 130 should give you 150. All right, example 3. There's nothing different here. This actually is easier than the previous problem. It just has decimals in it, so you guys get a little, I don't know, confused or think that you need to do something different. Which are the like terms? Let's find them. Well, we have terms with y. We have a 1y and we have a negative 0.07y. Well, if I want to combine those two, I can do them just by doing 1 and then minus 0.07. Well, what does that give me? It gives me a 0.93. All right, so 0.93y is what I have. And I still have, I didn't use this, so I'm going to do plus 1.24 equals 4.96. Just decimals, just like when I had above, I had a positive 6, so I used a negative 6 to move it to the other side. I have a positive 1.24, so I'm going to use a negative 1.24 to subtract it from the other side. And these will give me 0, and so I'll just have a 0.93y left on the left side, and I'll happily use my calculator, right, to make sure I'm doing the decimal subtraction correctly, and I should get 3.72. So I get 3.72. Well, now here some people also, again, get stuck because they're like, well, what do I do? Well, if this was just a 3y, you would divide by 3. But since it's not just a 3, it's a 0.93, we're going to divide by 0.93. It's still the same opposite operation. It's just that I'm multiplying by a decimal, but I'm going to divide by that same decimal. So take your 3.72 and divide it by your 0.93, and you should get 4. Okay, so 0.93 goes into that 4 times. So we know that y, these two canceled, right? Y equals 4. All right, so again, you've got one on the right side with decimals. Find your decimals, find your like terms, put them together, and solve from there. Again, in this case, you're going to get a decimal, and that's okay. Okay, so check your work on this one, right? Make sure that you're combining the like terms and then using opposite operations. Number 4 is really not that hard either, right? We have 2 like terms. They are 1/5 x and negative 3/8 x. And you might be saying, ooh, I don't know, I can't add and subtract fractions. Well, guess what? Your calculator can. So instead of spending time, working on how to make those similar fractions, let's talk about how to combine them. We've got a 1/5 minus a 3/8. Well, your fraction button in your calculator, we've learned, is this button, okay, the ABC. So we have 1/5, and then we need to just press over so we get out of that fraction and press minus, and then the fraction again, 3/8. Your calculator will do it for you. It is negative 7/40. Okay, so these two combine to give you negative 7/40x. 7. Now you have a one-step equation, right? This is just one step if you know how to use a reciprocal, right? Remember, we learned that the reciprocal is the opposite fraction. So 40 over negative 7 times 40 over negative 7, which cancel your 40s and your negative 7s, and you'll get x equals negative 7 times 40, and then divide by negative 7 should give you a 40. But if you are unsure of that, do it in your calculator, negative 7, and then do times the fraction of 40 over negative 7. And you'll see that it gives you 40. Try the fraction on this side. Use the calculator to combine the fractions, and then use reciprocals to solve. There you go. There's the answer for that one, right? It should be 12. Once you combine, get opposite fraction, use the reciprocal, and solve. Last one, hardest one, because there's 2 sets of distribution. So I'm going to start with 3 times c, should give you 3c, and 3 times negative 2 should give you negative 6. Most students forget that this is a negative 4, so this is a negative 4 times 2, which gives me a negative 8c, and a negative 4 times 3, which gives me a negative 12. And that should give me a 2 because that stays what it is. And now I've got 2 sets of like terms. I've got the c's and I've got the constants. So 3c and negative 8c, those are 2, right? And then negative 6 and negative 12 are going to go together. Negative 6. So 3c and negative 8c is going to give you a negative 5c, and negative 6 and negative 12 is going to give you a negative 18. Still equals 2. Right? Because this did not change. I only just combined my c's and combined my numbers by themselves. And now I just solve like I do any 2-step equation and start moving things to the other side. So these ones cancel. I get negative 5c equals 20, right? 2 plus 18 is 20, and then I divide by a negative 5. and I get C equals, right, negative 5's cancel, I get C equals negative 4. You can see that last bit of that? Okay, pause for the last one, and I'll put up the answer. All right, and there you see the answer to the final one right there. It is also a decimal. That's okay when things happen as a decimal. So your practice for this will be online. Please look at the Teams page to find the link for the practice problems. And when you're finished with them, come up to take your check.